Hi, it's Mrs. Nandor, and in this video we're going to be looking at the relationship between temperature and energy. So let's start with energy. The energy that we're going to be looking at is called thermal energy. Thermal energy is abbreviated E for energy, and then a subscript of TH to represent thermal. So it's E subscript TH. So that's our abbreviation for thermal energy. And our thermal energy is related to the speed of the particles. So if particles are moving faster, they have more thermal energy. If they're moving slower, they have less thermal energy. If we add thermal energy to a substance in the form of heat, we are going to speed up the particles. So if you have a beaker of water on a hot plate and you heat it, those particles are going to start moving faster. That's where the thermal energy goes. Thermal energy is going to speed up the particles. Opposite is also true. If we take thermal energy away, if something cools down, then the particles are also going to slow down as a result because they are losing their thermal energy. So now let's talk about temperature. Temperature is a way for us to measure the amount of thermal energy, which means it's a way for us to measure the speed of the particles. So as we add thermal energy to something, the temperature is also going to go up. So if we go back to our beaker of water, so if we have a beaker of water on a hot plate and we turn the heat on and we measure the temperature might be about room temperature at first. As we supply thermal energy, as those particles are moving faster, if we measure the temperature again, we're going to see that the temperature is higher. So if you add thermal energy, you're speeding up the particles and you're also going to see an increase in temperature. The opposite is also true. So as something cools down, as we usually think of it, it's losing thermal energy. We're seeing the temperature decrease because the speed of the particles is decreasing. Now let's talk about our temperature scales. We have two main temperature scales that we are going to use in chemistry. We have Celsius and we have Kelvin. The Celsius temperature scale is abbreviated with a degree symbol and then a capital C. And the Celsius temperature scale is based upon the freezing and boiling points of water. So the scientist named Celsius, who developed this scale, took a beaker of water and he heated it up, and when he saw that it was boiling, he measured the temperature, said that was 100. And he called it degrees Celsius because when you're a really smart scientist and you develop something new, you usually get to name it after yourself. So he said it was 100 degrees Celsius. Then he took that water, cooled it down, removed the thermal energy until it froze, so it changed from a liquid into a solid. And he called that 0 degrees Celsius. So 0 degrees Celsius is just the freezing point of water. This means that we can have things that have less thermal energy than frozen water because things can be colder than 0 degrees Celsius. We can have negatives. We can have all the way down to over negative 200 degrees Celsius. The Celsius temperature scale is simply just based on the freezing and boiling points of water, which means we can go over 100, we can go below 0. Just because something is at 0 Celsius, it does not mean the particles have stopped moving. It's just the relative speed based on water. If the particles are still moving, do they still have thermal energy? Well, yeah, because if particles are moving, they have to have some amount of thermal energy. So what about particles that have no thermal energy? All motion has completely stopped. Well, then we'd have a negative temperature. We'd have a negative degrees Celsius. Another scientist came around, Kelvin, and he said, well, let's adjust that so that 0 actually means 0 thermal energy. And that's when we got the Kelvin temperature scale. And Kelvin temperature scale is abbreviated just with a capital K. It's not degrees Kelvin, it's just Kelvin. And Kelvin is an absolute temperature scale. By saying it's an absolute temperature scale, it means we cannot have negative values. It means that 0 Kelvin is the complete absence of any and all thermal energy. So the particles have completely 100% stopped moving. So 0 Kelvin means no thermal energy, or no particle motion. 0 Celsius still has particle motion because the particles in solid water and ice are still moving, just a small amount. Kelvin is used to represent, 0 Kelvin is used to represent absolutely no movement. That's why it's an absolute temperature scale.